Welcome to this talk about knowledge in a risk context. Now, my name is Terje Arven, and I'm going to reflect on this important concept into a risk assessment, risk management context. Now, the term knowledge has been thoroughly discussed in the scientific literature, and we find many different definitions. Probably the most common you find in textbooks are this term here: justified true beliefs. Knowledge is justified true beliefs. Let's go back to Platon, the Platonian dialogue. But I will argue that it cannot be used in our context, because the term true, who is going to decide that these beliefs are true? That is the problem. Somebody have to say it's true, and then we are into problems. Take this simple example. I have a die. I got a die and I look into it. And I argue that it's because it's symmetric for different outcomes, 1, 2, 3, 4, 5, 6. The frequentist probability, the fraction of time you get 1, 2, 3, 4, 5, 6, would be 1 divided by 6. Now, I have some insights. I have some knowledge, I would say, but is it true? I don't know actually, and who knows? We can do later some experimentation and see what would be the fraction, but I could still argue that the frequentist probability is 1 divided by 6 based on this kind of reasoning of symmetry. So I have problem then with using justified true beliefs, and what is remaining is simply that knowledge must be justified beliefs, and the important thing is this kind of processes that we have for making these statements. We can call them reliable processes generating these beliefs. In our example, we use experimentation, we have judgments, argumentation. This is what we have in the as a toolbox in scientific work. Knowledge sometimes is referring to data. We have failure data, we're referring to information. We have some estimates of the failure rate of that system, and we have justified beliefs, for example, that the failure pattern would follow some probability model, for example, a Poisson model. Sometimes also referred to wisdom as the fourth element, which is basically saying that how we would use this data, information and beliefs in a proper context of decision making. And this kind of thinking as knowledge as justified beliefs, in my view, is perfectly matching this way of understanding science. Coming from Professor Svein-Ove Hansson from Sweden, that science is really producing these kind of justified beliefs, the most reliable statements that the various disciplines can produce. The different disciplines produce at any time some statements, and these are justified by the instrumented tools that this scientific area has. They have journals, they have dialogue, discussion, discourse, etc., etc. These are some examples saying that, trying to illustrate that knowledge and justified beliefs always has to be in some way or another to deal with uncertainties. There is, any statement that we're talking about is linked to uncertainties in some way. Look at these examples. The first one and the second one. A wall will withstand this load. A gas leakage of this size gives a flame length of 15 meters. We have done a lot of experimentation to get these kind of results. But they are accurate to some degree, because the statements are always conditional on certain assumptions. And given these assumptions, we get these kind of results, show the experiments. But if you take these assumptions away, there will be variations. We are coming into the area of uncertainty and probability. And also for C and D, in case C, we are saying that the figurative probability of the system fail is less than X. Well, what we can do is really to say that we can have an estimate of this figurative probability of the system failure being less than X. We cannot produce the exact probabilities unknown. We have to estimate it. So we have some uncertainties. And in case D, we foresee no serious side effects of this treatment. Well, there will always be some uncertainties, and the justified beliefs, the statements, have to relate to uncertainties in some way. So to summarize, knowledge is justified beliefs, and the importance of scientific work is to produce this justification. We cannot refer to true, because then we are into a problem who decide what is true, and we always have to relate these kind of statements to uncertainties, variations, as seen in these examples. Thank you.